Welcome to Tomorrow Unveiled. Have you felt that profound shift happening in the global energy landscape? It's more than just a typical news cycle.
Oh, definitely. The past week especially seems to have just accelerated this transformation.
Yeah, driven by, well, unprecedented global investment and some really significant regulatory breakthroughs.
It's a rapid unfolding of events, really. It kind of compels us to look at energy through a new lens.
Right, what we're calling green code hot core.
Exactly.
So let's unpack that. Green code, as we understand it, represents, well, the absolute non-negotiable need for deep decarbonization, right? Cleaning up our energy system.
Precisely. That's the foundation. And hot core signifies the pivot towards a specific group of technologies. Think high density, reliable,
Land efficient.
and land
Wow.
efficient. Exactly. Clean energy, we're talking advanced nuclear fission, nuclear fusion, and deep geothermal.
Okay, so these aren't niche solutions anymore.
Not at all. They're, becoming much more central to our energy future.
And why is this shift so critical, like right now? Our research team flagged something they called a structural demand shock.
Yeah, that's a good way to put it. Think about the exponential growth in electricity demand from AI and data centers.
Right, they're huge users.
Huge.
Uh,
And they're geographically concentrated, and they demand 24/7, 365 reliability. Rain or shine, it has to be there.
that's a totally new demand profile, isn't it?
It is. And then you add in the broader economy-wide electrification, plus those recent heat waves straining power grids like across the U.S.
Yeah, that really highlighted the need for something more robust.
It all just points to this urgent need for firm dispatchable power.
That phrase, firm dispatchable power, explain that a bit more.
Sure. It just means electricity you can essentially turn on and off or, ramp up and down whenever needed, irrespective of the weather or the time of day.
Got it. So reliable on demand.
Exactly. And the past week's events really show this isn't just like a continuing trend, it's accelerating dramatically.
Why so fast?
It seems to be this powerful convergence. You've got transformative government policy, massive corporate buying, and real technological maturation all hitting at once.
Okay, and that's our mission today on Tomorrow Unveiled. We're going to, dive deep into the sources our dedicated research team compiled,
Hmm.
pull out the most important insights, maybe some surprising facts to help you understand what this green code hot core paradigm truly means for the future of energy.
Sound good.
So, with this urgent need for firm power, let's jump right into that accelerating pivot towards high-density energy. This new demand landscape, it really is unlike anything we've seen before.
Yeah, the sheer scale of this structural demand shock for AI and data centers is just extraordinary.
It's not just that they need massive amounts of power.
Right, it's that they need it constantly,
Yeah.
reliably, which frankly current grids struggle to deliver just with intermittent sources like wind and solar.
And those heat waves you mentioned.
They were a real-world stress test, weren't they?
Yeah.
They just underscored this critical need for climate-resilient power, power that doesn't falter when temperatures soar.
And it's not just about what we need, it's also where the money's going, right? The research we looked at indicates a massive shift in capital.
Huge. Global investments in electricity are now projected to be roughly 50% greater than fossil fuel expenditures.
Wow, 50% more.
Yeah, that's a huge reallocation in capital, straight towards bolstering our electric grids.
And this reallocation, it sort of underscores what you called a watershed moment.
I think so, yeah. We're seeing, like I said, transformative government policy, massive corporate procurement, think big tech companies buying clean power, and real technological maturation all converging.
And this convergence is what, fundamentally reshaping things?
Yeah, the investment and deployment landscape. We're moving away from this singular renewables-only narrative that dominated for a while.
So it's more of a dual track reality now.
Exactly. We're both variable clean energy, like solar and wind, and firm, high-density clean energy are being aggressively pursued as complements.
Not one or the other.
No, definitely not. Both working together, hopefully in synergy, for, resilient decarbonized future.
Okay, so with that new reality in mind, let's explore some of the key breakthroughs forging this hot core. First up, advanced nuclear fission. SMRs, microreactors. The regulatory progress here seems pretty monumental.
It really has been. The U.S. Nuclear Regulatory Commission, the NRC, they just hit a landmark. Final design approval for NuScale Power's uprated small modular reactor.
Okay, and why is that so significant?
Well, NuScale is now the only company with NRC design approval for 2 different power ratings. That really solidifies their position, in this emerging market.
Right. And there was another NRC move around June 17th.
Yes, that was maybe even more impactful. A pivotal policy shift.
Yeah.
They significantly lightened the regulatory burden specifically on microreactors.
Us.
This new policy allows for factory fuel loading and operational testing under, let's say, more lenient rules.
And practically, what does that mean?
It drastically reduces the pre-deployment hurdles,
Yeah.
the timelines, the costs. It's potentially a game changer for getting these, compact reactors deployed much faster.
Okay, faster deployment. But the question then is, how quickly can these actually scale up? Are we seeing momentum there?
We are definitely seeing momentum. Take the BWRX-300 ecosystem, for example. That's GE Hitachi's design.
Okay.
It's solidifying globally. They just signed a memorandum of understanding with the UAE's Emirates Nuclear Energy Company.
Interesting. International reach already.
Yeah, and domestically. Major U.S. utilities, TVA, AEP, Duke Energy, they're coordinating efforts. They're seeking federal funding to accelerate BWRX-300 deployment.
How soon could we see those?
Potentially the late 2020s or early 2030s. That's the target.
And speaking of accelerated deployment, that deal between Amazon and Talon Energy, that seemed like a big deal.
Oh, huge. A landmark corporate power purchase agreement, or PPA. It's a major template setter.
So Amazon is buying power directly from a nuclear plant.
Yep, 1,920 megawatts of 247 carbon-free power from the Susquehanna nuclear plant until 2042, all to power its data centers.
Wow. And why is that a template setter?
Because it's a new financing model. You have a massive tech company basically providing a long-term revenue guarantee that de-risks the huge upfront capital needed for these nuclear projects.
So the corporate demand is actually helping finance the supply.
Exactly. A perfect example of the market responding directly to that demand for firm power. And private funding is flowing in too.
Like what?
Well, Nano Nuclear Energy just closed a $105 million private placement. And Bill Gates' TerraPower raised another $650 million.
TerraPower, right. With NVIDIA's venture arm joining in.
That's the one for their natrium sodium-cooled reactor. They're aiming for a pilot plant. These are, clear signals of growing investor confidence.
Okay, so deployment and funding are moving. What about the fuel side, especially the waste issue?
Yeah, good point. There's innovation there too. Moltex Energy announced a breakthrough with its Watts process waste-to-stable salt.
Watts, what does it do?
They've successfully recovered over 95% of the transuranic elements from used reactor fuel.
Those are the really long-lived, problematic ones, right?
Exactly. And this process can potentially reduce the volume of that long-lived waste by up to 80%.
80%? That's incredible.
It is. And get this, it could even create new fuel for molten salt reactors.
So turning waste into fuel.
Essentially, yeah. Transforming what was seen as a liability into potentially a valuable resource. It's a big leap.
Okay, so that's fission looking much more dynamic. Now let's turn to the fusion frontier. Our research didn't flag any, major net energy game breakthroughs this past week.
No, not in terms of hitting that big milestone. But the sector has seen significant strides, particularly in strategic collaborations and industrial progress.
What kind of strategic shifts?
Well, one that stands out is the International ITER project. It's formally opening its doors to collaborate with private fusion companies now.
Really? The big public project working with private startups?
Yep. Commonwealth Fusion Systems, CFS, is the first one to officially join. It signals this critical recognition, I think, that public and private sectors need to work together to speed things up.
And it's not just talk. Are they actually building things?
We're seeing tangible industrialization efforts, yes. CFS recently visited their manufacturing partner CIMIC in Italy.
What for?
For the Spark project's massive magnet cases and cryostat walls, this isn't just R&D anymore. This is actually building the real-world supply chains needed for future fusion plants.
So the nuts and bolts are starting to come together.
Right. And investor confidence seems solid, too. Keeling closed a $425 million funding round.
Helion, okay. That brings their valuation up pretty high.
To about $5.4 billion, yeah. And attracting new heavyweight investors. It just shows strong market conviction, that progress is being made towards commercial fusion, even if it's still a ways off.
Okay. Fission moving, fusion industrializing. Let's look at the third part of the hot core. Geothermal's global ascent, tapping Earth's baseload power.
Yeah, and we're seeing really significant commercial validation here, especially for enhanced geothermal energy. or EGS.
EGS, right. That's where they create permeability in hot rock.
Exactly. And Southern California Edison just signed the world's largest ever power purchase agreement for EGS.
The largest ever.
Yeah, a 15-year deal for 320 megawatts from Wells in Utah, enough to power around 350,000 homes.
That's huge. A monumental agreement, really.
It absolutely is. It demonstrates geothermal's ability to compete head-to-head as a firm, clean power source.
And is this just a U.S. thing, or is it happening globally?
Globally, too. In Kenya, the state-owned utility Kengen announced its Olkaria geothermal project expansion is already 70% complete.
Bulgaria. Okay. How much power is that adding?
It's set to add 63 megawatts by June 2026. And that directly supports Kenya's really ambitious goal of 100% clean energy by 2030.
So that's real-world execution at scale happening right now?
Absolutely. Real progress on the ground.
Okay, before we dig deeper into why this hot core offers such unique value, we wanted to just briefly mention how you can support Tomorrow Unveiled. It really helps us reach more listeners.
Yeah, definitely. If you're finding this insightful on YouTube, please take just a moment to like this video, subscribe to Tomorrow Unveiled, of course, and maybe turn on notifications so you never miss an update on the future.
And if you're listening on a podcast service, maybe Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and a review for Tomorrow Unveiled. It truly does help us reach new listeners.
It really does.
Okay, so with that said, let's get back to the hot core value proposition. Why does energy density matter so much? We know low-density renewables, solar and wind, they've seen massive scale-up.
Oh, absolutely massive. Our research shows China, for instance, installed something like 93 gigawatts of solar and 26 gigawatts of wind in just 1 month last year.
That's staggering. An incredible amount of capacity.
It truly is. But, and this is the key challenge, this massive scale-up of intermittent sources, it often runs into grid constraints.
Meaning the grid can't always handle that much variable power.
Right. And as global energy demand rises even faster, it creates what we call a reliability gap.
A reliability gap.
Yeah, a grid with a really high penetration of variable renewables will eventually expose this gap. And that makes firm, dispatchable power absolutely essential just to keep the lights on reliably.
Okay. So our research team compiled some comparisons, quantitative stuff.
They did, yeah. And they really drive this point home. Look at capacity factor. That's basically how much of the time a power plant is actually generating electricity.
Okay.
Nuclear and geothermal consistently operate at over 90%.
90% plus.
Now compare that to solar PV, typically 15–30% depending on location and type. And onshore wind, maybe 30–50%.
That's a huge difference in consistency.
It's a profound difference in reliability and consistency, exactly.
And this density, it translates to environmental footprint too, especially land use.
Directly. A much lighter footprint. The data we looked at shows nuclear requires roughly 1.3 acres per gigawatt hour per year.
Yeah.
Geothermal, around 9.9 acres.
Okay, 1.3 and 9.9. How does that compare?
Significantly less than solar PV, which needs around 43.5 acres, and onshore wind, which can be as high as 135 acres per GW per year.
Wow, so nuclear uses, what, like 30-something times less land than solar?
Up to 34 times less land than solar PV for the same energy output, yeah. It's like building a power plant the size of a city block instead of one that stretches for miles.
That's a game changer for land-constrained areas or just preserving natural spaces.
Absolutely.
And it's not just land dispatchability. You mentioned that earlier.
Right. Nuclear and geothermal are fully dispatchable. You can turn them on, turn them off, ramp them up or down to meet demand whenever needed.
Unlike solar and wind.
Unlike solar and wind, which are intermittent, they depend entirely on, well, the sun shining or the wind blowing.
Okay. What about broader sustainability impacts, materials, waste?
Well, energy density generally means fewer material needs overall per unit of energy. And we're seeing real progress on waste reduction, too.
Like the Moltex Watts process you mentioned.
Exactly. Significantly reducing those long-lived waste volumes. And globally, there's also concrete progress on permanent storage solutions, like Sweden's plans for a deep geological repository at Forsmark. That addresses a long-standing challenge.
Right. And emissions. How does nuclear stack up?
It's crucial to remember nuclear's life cycle emissions from mining uranium to decommissioning are actually on par with wind and solar. Very, very low.
So they avoid huge amounts of CO2 over their operating lives.
Massive amounts. Plus, these projects, these large infrastructure projects, they bring significant social and economic benefits. High-quality jobs, often long-term.
And maybe just transition opportunities for communities moving away from fossil fuels.
That's definitely part of the conversation, providing new opportunities in those areas.
Okay, so a strong value proposition. Now, looking ahead, let's talk outlook. How do these technologies integrate? What are the timelines? And what headwinds do they still face?
Right, projecting timelines is always tricky, but the events of the last week or so, they do allow for maybe more confident projections.
Okay. For SMRs, for instance.
Well, in the U.S., that executive order mandating an 18-month timeline for NRC new reactor approvals, that could be a potential game changer if they'd stick to it.
18 months from application to approval.
That's the target. It means the first commercial SMRs in the U.S. could potentially break ground within, say, 2-3 years, with commercial operation maybe by the late 2020s.
That is a significant acceleration compared to past timelines.
It really is. Now, for nuclear fusion, obviously still a longer-term prospect.
Right.
But those strategic public-private collaborations like ITER and CFS, coupled with the major funding rounds we're seeing, it supports an accelerated path, I think. Demonstration plants achieving net energy gain by the late 2020s seems more feasible now.
And that could pave the way for commercial plants when? Mid-2030s, late 2030s.
That's the hope. Maybe mid to late 2030s for the first commercial fusion plants. Still a lot of hurdles, but the momentum is building.
And geothermal, what's the outlook there?
Well, that landmark EGS power purchase agreement in the U.S., that's a really powerful market signal.
Suggesting more capacity coming online?
I think we can expect a significant increase in geothermal capacity, especially in the U.S. West, probably before 2030. It could play a crucial role in firming up grids that have a lot of solar already.
Okay, so promising timelines, but it can't all be clear sailing. What are the persistent headwinds, the hurdles?
Oh, definitely hurdles remain. For SMRs, one major challenge is just achieving the scale needed for mass production. It's kind of a chicken and egg problem.
You need orders to build factories, but buyers want to see proven factory production.
Something like that. We also absolutely need to build a robust domestic supply chain for HALEU fuel.
HALEU, high-assay, low-enriched uranium, that advanced fuel.
Right. We currently don't produce enough domestically, which creates a strategic reliance on other nations, primarily Russia, which is problematic.
Yeah, that's a big one. Anything else for SMRs?
Lack of harmonized international regulations makes global deployment harder, and frankly, competition from state-owned enterprises in other countries.
Okay. What about fusion? What are the big hurdles there?
Well, the lead from physics demonstrations to actual economically viable power plants is immense. Huge challenges remain in fundamental engineering.
Like what?
Materials, science, finding materials that can withstand the intense conditions inside a fusion reactor for long periods. Efficient heat extraction is another big one. And tritium-breeding fusion reactors need to produce their own tritium fuel, and that's really complex.
So, major engineering problems still to solve.
Yes, and they'll require sustained multi-billion-dollar investment over many years.
And geothermal, what are its main barriers?
High upfront capital costs are a big one. Drilling deep wells is expensive, and there's significant drilling risk you might not find the resource you expect.
So, financial risk.
Right, and public perception concerns, particularly around induced seismicity.
Minor ground vibrations from drilling.
Very minor, usually undetectable without sensitive instruments, but it needs careful communication and management. Plus, there's often a need for clearer regional strategies to really attract investment and streamline permitting.
And across the board, general challenges.
Workforce development is huge. Training enough skilled people, supply chain capacity for all these advanced components, and of course, navigating complex geopolitical factors.
Okay. So as we wrap up this look into green code, hot core, it feels pretty clear this paradigm isn't just theoretical anymore.
Not at all. The events of just the past week or so provide really compelling evidence, I think, of a powerful synchronized shift.
Yeah.
Governments, capital markets, major corporations, they're all moving towards prioritizing these high-density clean energy sources.
And that synergy you mentioned between AI's huge power demand and the nuclear industry's evolving capabilities.
It's creating a potent new economic engine, really. An engine for decarbonization, yes, but also for economic growth. The intrinsic value of energy density, that 2047 reliability, national energy security.
That's commanding a higher premium now.
An ever higher premium, it seems, in a world facing growing demand and, let's face it, geopolitical instability.
So the question isn't really if these technologies will play a major role anymore.
No, I don't think so. It's much more about how fast they can be deployed, how quickly can we scale them up to meet these dual challenges of climate change and economic progress.
We're truly moving towards a future that's not just about more energy.
But smarter energy,
Huh.
denser energy, more resilient energy.
So here's a final thought to leave you with. What might a truly integrated, resilient energy future look like? Where these hot core technologies work in synergy with fast renewable fleets, all optimized by smart grids, maybe even AI managing the whole system.
It's a fascinating picture to consider.
And how might you contribute to, or how might you be impacted by, this accelerating energy transformation? We always love hearing your thoughts, whether you're on YouTube or your favorite podcast app. Please leave a comment and let us know what you think about green code, hot core, and the future of energy.
Yeah, we'd love to hear from you.
Thanks for joining us on Tomorrow Unveiled. We'll see you next time.